Good afternoon, everybody. I am Sujata Talur, Assistant Professor, Department of Mathematics, Government Degree College, Kalgatti. Today, let us study about the degree splitting graph of a graph. For this, we have to know the definition of a graph. By graph, we mean the set of vertices and the set of edges. Vertices means points and edges means lines. So in this example, there are 7 vertices and 8 edges. So 1, 2, 3, 4, 5, 6 and 7 are the vertices. So they are kept in vertex set, and edges 1, 2, 1, 3, 2, 4, 4, 5, 3, 5, 4, 5, 5, 6 and 6, 7 are the edges. Since there is no edge joining 2 and 3, so it is not included in the edge set. Let us move to the order and size of the graph. By order, we mean the number of vertices in the graph, and by size, we mean the number of edges of the graph. So the minimum possible order is 0, that is empty graph, null graph. And the maximum possible order is a complete graph, that is n into n minus 1 divided by 2. For example, here in the graph G, x is a edge joining A and B, where A and B are 2 vertices. So let us move to the definition of degree of a vertex. So let G be a graph and V be the vertex of G. Then the degree of V is the number of edges of G incident with V, and it is denoted by degree of DEG of V or DEGV. Let us take an example. Here we have a graph G where the degree of the vertex A is 1, since there is only one edge incident with A, and the degree of B is 3, since there are 3 vertices incident with B, and the degree of C and D are 2, since there are 2 edges incident with C and D respectively. Now we'll know about the sum of the degrees of the vertices of each graph. So in this first graph, the sum of the degrees of the vertices is 12, the second one 20, and the third one is also 20. Only thing we are doing is we are adding all the degrees, all the sum of all the degrees of the vertices. Let us move to the main definition, which is the degree splitting graph of a graph G. Let G be a graph with vertex and edge set, and then let capital V is S1 union S2 union S3 so on union ST union T, where each SI is a set of vertices having at least 2 vertices and having the same degree. And T, by T we mean that vertex set minus union of SI. So the degree splitting graph G denoted by ds of G is obtained from G by adding the vertices W1, W2, so on Wt, and joining Wi to each vertex of Si. Let us see some examples. See, this is a graph G where all the vertices are of degree 2. So we add only one vertex and we join that vertex to all the vertices of degree 2. So that is ds of G. Similarly, we take this example. This is a graph G where U1 is vertex of degree 1. U7 is vertex of degree 1. Since those are the vertices of degrees same degree, we'll add a vertex W1 and we will join W1 to U1 and U7. Let us take the vertices of degree 2. Here U2 is a vertex of degree 2 and U6 is a vertex of degree 2 and U5 is a vertex of degree 2. So we add a vertex W3 to the vertices of degree 2, that is U2, U6 and U5. Next, let us move on to the next one of degree 3. There are only two vertices of degree 3, that is U3 and U4. So we add a vertex W2 and we join W2 to U3 and U4. This is the new graph, that is degree splitting graph generated from a graph G. So a graph is said to be connected if every pair of its vertices are joined by a path. A graph which is not connected is said to be disconnected. So a graph whose edge set is empty is called totally disconnected graph or a null graph. So here G is a totally disconnected graph, but the degree splitting graph of a disconnected graph is a star because all the vertices are of degree 0. So we take one new vertex and we join that vertex to all the points. So it is a star. Now let us take this example where G is a graph with 4 vertices and all the 4 vertices are of degree 3. So we add a new vertex and we join that vertex to all other points. So this is degree splitting of G. So thank you one and all.